Hello and welcome to another episode of Maths Whenever. In this video we're going to look at the algebra of subtracting, multiplying and dividing negative numbers to prove the three rules. A minus negative b equals a plus b. Negative a times negative b equals a times b. And finally, negative a divided by negative b equals a divided by b, where a and b are pronumerals that represent numbers. In all three of these rules, the two negative signs on the left-hand side of these equations cancel out, and in this video we're going to see why. But first, let's get a perspective on the relationship between positive and negative numbers. Positive and negative numbers can be visualised by placing them on a horizontal number line. Positive numbers are placed to the right of 0, while negative numbers are placed to the left of 0. These sets of numbers go off to infinity in both directions. This visualisation will be particularly useful when we look at subtracting negative numbers. And here's Sarah to explain.
Thank you, Mr. Cater. Part 1. The mystery of why a minus negative b equals a plus b. First, we will show algebraically that a minus negative b equals a plus b, and then complement this algebra with examples using counters and the number line. Don't worry, the algebra will be simple. So how do we make sense of subtracting a negative algebraically? First, we begin with a. Next, we add 0 since adding 0 has no effect on a. We can re-express this 0 as b minus b, since b minus b equals 0. Now we subtract the term negative b, and when this is done, we are left with a plus b. The left-hand side of this equation is what we did, and the right-hand side is what we got. We can demonstrate this algebra with simple counters. Here is a blue counter that represents positive 1, and a red counter that represents negative 1. When these are added together, the result is 0, since the sum of positive 1 and negative 1 equals 0. As an example, we will now show that 2 minus negative 3 equals 5. Here are two blue counters representing positive 2. We will now add 0 3 times as 3 pairs of positive 1 and negative 1. The net result of adding these pairs is still positive 2 because adding 0 has no effect. Now let's subtract negative 3 by removing 3 red counters. We are now left with the original 2 blue positive counters plus 3 extra blue positive counters. This makes a total of 5 blue positive counters, which represents positive 5. Hence, the expression 2 minus negative 3 is equivalent to the expression 2 plus 3, as both expressions equal positive 5. We will now show the same result using a number line. The key to understanding subtraction is to think of subtraction as a difference between two numbers, or the distance between two numbers on a number line. Let's begin with the difference or distance between 2 and 2. Obviously, the difference between 2 and 2 is 0, and this is done by subtracting 2 from 2, since 2 minus 2 equals 0. Now let's look at 2 minus 1, whose difference or distance is 1, since 2 minus 1 equals 1. Similarly, with 2 minus 0, whose difference or distance is 2, since 2 minus 0 equals 2. So far, both numbers have either been positive or 0. But what happens when the second number itself is negative? It is this situation that involves the subtraction of a negative number. Think about it for a moment. The answer should be self-evident. The difference or distance between the two numbers gets larger. So 2 minus negative 1 equals 3. But 2 plus 1 also equals 3. Continuing this, we then see that 2 minus negative 2 equals 4. But 2 plus 2 also equals 4. Continuing this again, we then see that 2 minus negative 3 equals 5. But 2 plus 3 also equals 5. Note that this is the same result we obtained when we used counters. Generalizing this pattern, we can then say that a minus negative b equals a plus b. This isn't some abstract concept that mathematicians made up. Here is an example from the real world where subtracting a negative occurs. This is the symbol of an operational amplifier, or op-amp for short. An op-amp is an analog integrated circuit consisting of dozens of electronic components called transistors, resistors, and capacitors. Here is what a single op-amp integrated circuit looks like. Its real size is about 1 cubic centimeter. These can be made even smaller and are found in many electronic devices, including computers and mobile phones. The term operational refers to the mathematical operations that these amplifiers can do. They can carry out arithmetic, that is, add, subtract, multiply, and divide, and even the calculus operations of differentiation and integration. With a few extra resistors, the op-amp can be made into a difference amplifier to subtract 2 voltages. Remember that a difference is found by the mathematical operation of subtraction. If the first voltage V1 is positive 2 volts and the second voltage V2 is negative 3 volts, then the output voltage Vout will be the difference between positive 2 volts and negative 3 volts, which will be positive 5 volts. This amplifier circuit can be built for just a few dollars. Part 2. The mystery of why negative A times negative B equals A times B. Just as in Part 1, we are going to use some very simple algebraic rules. The first rule is negative A times 0 equals 0. That is, anything times 0 equals 0. We will call this equation 1. The second rule is B minus B equals 0. That is, any number minus the same number is always 0. We will call this equation 2. We are now going to substitute equation 2 into equation 1. This gives us negative A times B minus B equals 0. Now, since subtraction is the same as adding a negative, the equation can be rewritten as negative A times B plus negative B equals 0. We are now going to use the distributive law to expand the brackets on the left-hand side of the equation. First, negative A times B equals negative AB. Then, negative A times negative B equals negative A times negative B. And of course, the right-hand side is still 0. Looking at what we have done so far, you might think that this is all pointless and getting us nowhere. But these steps are important as they lead to the final step. Can you see what this final step is? We add AB to both sides of the equation. This will cancel the negative AB term on the left-hand side because negative AB plus AB equals 0. And on the right-hand side, 0 plus AB equals AB. And so, negative A times negative B equals A times B. Here is an example using op-amps again, where multiplying two negatives results in a positive. This op-amp is now configured as an inverting amplifier with a gain of negative 2. This means that the output voltage Vout is twice the size of the input voltage Vin, and with the opposite sign. If we make the input voltage negative 3 volts, then multiplying this by a gain of negative 2, the output voltage will be positive 6 volts, since negative 3 volts times negative 2 equals positive 6 volts. This amplifier circuit can also be built for just a few dollars. The often overlooked consequence of multiplying two negative numbers is that if those two numbers are the same, then we have the following. Negative A times negative A equals negative A squared equals A squared equals A times A. This means that the square root of A squared equals A and negative A, or simply plus or minus A. Hence, there are always two answers to the square root of any positive number. For example, the square root of 1 equals plus or minus 1 because 1 times 1 equals 1, and negative 1 times negative 1 also equals 1. The square root of 4 equals plus or minus 2 because 2 times 2 equals 4, and negative 2 times negative 2 also equals 4. The square root of 9 equals plus or minus 3 because 3 times 3 equals 9, and negative 3 times negative 3 also equals 9. And so on. The first to realise this was the 12th century Indian mathematician Bhaskara II. Part 3. The mystery of why negative A divided by negative B equals A divided by B. Before showing generally that negative A divided by negative B equals A divided by B, we first need to show specifically that negative 1 divided by negative 1 equals 1. First, we begin with the simple fact that negative 1 equals negative 1. Now, multiplying the right-hand side by 1 won't alter the equation because multiplying by 1 has no effect. We now divide both sides by negative 1. The two negative 1s on the right-hand side cancel because any value divided by itself is always equal to 1. This leaves us with the fact that -1 divided by -1 equals 1. With this fact, we can now proceed to show generally that -a divided by -b equals a divided by b. We begin with the quotient -a divided by -b. We can rewrite the quotient by factoring out -1 from both the numerator and the denominator. Next, we split the single fraction into two fractions. Having shown that -1 divided by -1 equals 1, the right-hand side becomes 1 times a divided by b. And since multiplying by 1 has no effect, it can be cancelled and the quotient on the left-hand side equals the quotient on the right-hand side, which shows us that -a divided by -b equals a divided by b. Here again is an example using op-amps where dividing two negatives results in a positive. This is the same inverting amplifier, with a gain of -2 we saw in the previous example when we multiplied two negatives to obtain a positive. This time we will analyse the circuit in reverse, since division is the reverse of multiplication. If we want the output voltage Vout to be -6 volts, what does the input voltage at Vin have to be? To answer this, we divide the -6 volts by the gain of the op-amp, which is -2. When we do this division of -6 divided by -2, we see that by the rule, Vin must be and will be +3 volts. You now know why, when subtracting a negative value, a minus -b equals a plus b, when multiplying two negative values, -8 times -b equals a times b, and when dividing two negative values, -a divided by -b equals a divided by b. We hope you now appreciate the algebra of subtracting, multiplying, and dividing negative numbers. Your understanding of algebra is always improved when you appreciate how its rules work. If you like this video, then please like, share, subscribe, and add a comment. You can also check out more videos at Maths Whenever on YouTube. And for a collection of other mathematical stuff, follow iPhi on Instagram, where I is the imaginary unit, phi is the golden ratio, e is the exponential function, and pi is the ratio of a circle's circumference to its diameter. Finally, if you're a mathematics student in secondary school and would like to take more control of your learning, then the Maths Factory website is definitely worth checking out. It has a collection of maths videos to help you review a concept and how to use the TI-CAS calculator. Thanks for watching and see you next time.